Welcome to Applied Mathematics 1, Lesson 10. The applications of differentiations. This subsection shows how to locate and identify extreme, maximum or minimum values of a function from its derivative. Once we can do this, we can solve a variety of optimization problems. The global maximum, it's a global maximum called an absolute maximum of a function f on a closed interval I. Is a value f of c such that f of c greater than equal to f of x for all x in I. The global minimum, a global minimum also called an absolute minimum of a function f on a closed interval I is a value f of c such that f of c less than equal to f of x for all x in I. Maxima and minima are collectively known as extrema. Identify for extreme value theorem. But how to identify types of maxima and minima for a function with domain a less than equal to x less than equal to b? Maybe you can give the practical appropriate to the following function. A critical number of a function f is a number c in the domain of f such that either f derivative at c must be 0 or f derivative at c must be does not exist. Maybe you can check the graph. After we have a sketch like this, and from the left one up to the negative integer, or from the second quadrant up to the third quadrant, here is the local maximum and the local minimum. But in the first quadrant and the fourth quadrant here, there is a global maximum and the global minimum, which is known as the global maximum is the absolute maximum. But the global minimum must be the absolute minimum. The closed interval values method. To find the absolute maximum and minimum values of a continuous function f on a closed interval from a, b. First, find the values of f at the critical numbers of f in a and b. Second, find the values of f at the endpoints of the interval. Third, the largest of the values from steps 1 and 2 is the absolute maximum value. The smallest of these values is the absolute minimum value. Don't forget there is another topic that you have learned on mathematics student textbook in grade 12 about Royalists Theorem. If a function f of x is continuous on the closed interval, a and b is differentiable on the open interval a and b and f of a which is equals to f of b, then there exists at least one number c in the interval a and b such that f derivative at c must be 0. So we have identified by calculating here, we sketch the graph such like the Rolle's function with the mean value theorem. When we go to the mean value theorem, if f of x is continuous on the closed interval a and b where a less than b and differentiable on the open interval a and b, there exists at least one c in the open interval a and b such that f derivative at c must be f derivative at f of b minus f of a over b minus a. So this is about what we have created about the applied mathematics 1.